When doing an extraction, we did a method of liquid extraction, which is basically separating the compound between two immiscible layers based on their solubility. For example, on the picture to your left, you'll see inside the separatory funnel two liquids separated because they're immiscible, and also you want them to reach equilibrium. So in order to reach equilibrium, you would swirl the separatory funnel as demonstrated in the video right down below.
Nice.
This will allow the benzoic acid to fully reach equilibrium between methylene chloride and the aqueous layer, and then you'll just let it sit there so it could distinguishedly separate between the two layers.
So the question you may ask yourself is benzoic acid soluble in both water and methylene chloride? The answer is yes. Why? Because as you see here, the water molecule is polar, and part of the benzoic acid molecule here is also polar. And in the other case, you have the nonpolar methylene chloride, which is here, and then the nonpolar benzene ring, which is found in the benzoic acid molecule. Why is it more soluble in one than the other? Because the benzene ring is larger and nonpolar in comparison with the methylene chloride, which is also nonpolar, so that will make this benzene ring more attracted to the methylene chloride, which is why benzoic acid is more soluble in methylene chloride. So now we will move on to comparing single versus multiple extraction. In the single extraction, you see here we got 0.0621 grams of benzoic acid versus multiple extraction, which we got 0.0385 grams of benzoic acid. That means that less benzoic acid was extracted with the methylene chloride in this case, since we have more of it. And in the multiple extraction, less benzoic acid was kept, which meant that more of it was left with the methylene chloride. So which is more efficient? Well, the multiple extraction was more efficient because less benzoic acid is kept, which meant that there is less base required to neutralize the acid.
So when doing liquid extraction, we come to a new concept called partition coefficient or distribution coefficient. The distribution coefficient is basically the ratio of concentration of the species, which is in this case is X, within the solvent 1 and solvent 2. The partition coefficient can estimate the ratio of solubility within the solvent 1 and solvent 2. As you can see from the formula in the bottom left, when there's more solute extracted within the solvent 2, which is usually the organic, there's a higher Kp. On the other hand, when the extraction isn't efficient and there's more solute in the aqueous solvent, as right here, there's a smaller Kp. So this indicates that multiple extraction will have a better Kp. The Kp is calculated by calculating the amount of extraction of the solute calculating the amount of extraction of solute depending on the amount of volume needed for the solvent. So on that ratio, that will give you the Kp. We were able to calculate the amount of benzoic acid extracted by separating the two layers of the aqueous and organic immiscible layers, taking out the organic layer first, leaving the aqueous layer within the separatory funnel. After that, we were able to titrate it, as shown in this video. And knowing how much NaOH was used within the volume, we were able to calculate the amount of mass of benzoic acid within the aqueous layer, and we subtracted that from the total amount. Of benzoic acid originally used, and then we were able to get the amount of benzoic acid within the methylene chloride layer. And through this, we were able to calculate how much benzoic acid was actually extracted within each layer, giving us the KD, which then gave us then we were able to do the percent error in the multiple extraction to see how much we were actually able to extract.
In this experiment, we explained how extraction was conducted by answering the following questions. What is liquid-liquid extraction? Is benzoic acid soluble in both water and methylene chloride? And why is it more soluble in one than the other? We also contrasted single extraction and multiple extraction methods and which was more efficient. We also explained what KD was and its usefulness and how we were able to calculate it. And we also determined the amount of benzoic acid extracted.